students, myself Dr. Divya, Assistant Professor, Department of Chemistry, Institute of Aeronautical Engineering. In this session, we will learn and understand the ultimate analysis of coal for its practical applications. So here are the topics. What is ultimate analysis? How is it defined? Then presence of elements. So what are the elements that are present that we are going to analyze in the ultimate analysis? Like carbon, hydrogen, nitrogen, sulfur, oxygen. So next is the significance of this ultimate analysis, how it is significant in our practical applications, and summary of the analysis, whatever it be done. So ultimate analysis, here coal is composed primarily of carbon. So mostly we will contain carbon. Carbon is in large quantities. So carbon will be in large quantities along with some variable quantities of other elements. So what are these elements? Hydrogen, sulfur, oxygen and nitrogen. Hydrogen, sulfur, oxygen and nitrogen are present in some amounts in all the types of coals. So this ultimate analysis is also called as elemental analysis. Why is it called elemental analysis? Because we are analyzing elements qualitatively. So we are analyzing in percentages basis for all the elements like hydrogen, sulfur, oxygen and nitrogen. Therefore, ultimate analysis is also called as elemental analysis. Also called as elemental analysis. Elemental analysis. So this involves carbon, hydrogen together we will be doing, then nitrogen, sulfur and oxygen. The shortcut CHNSO. So this is how we need to remember for the ultimate analysis of coal. So CHNS and O. These are the elements we will be testing in the ultimate analysis of coal. So how are they really present in the coal? So fixed carbon. So total carbon is nothing but fixed carbon that is present in the coal plus carbon present in its volatile matter. So it is present in the form of volatile matter and also fixed carbon. So these two together will give total carbon. So these two together will give total carbon. So high total carbon represents high calorific value of the fuel. So we are very much favorite, like our intention is to have high energy coming out from that fuel. So that will happen only if we have high calorific value of that particular fuel. So that is obtained only when we have high carbon content. Next is the hydrogen. How is hydrogen present? It is present in association with volatile matter. Any organic compound will contain carbon and hydrogen. So this increases calorific value and hydrogen remains as coke oven gas. So this is present in the form of volatile matter. So from peat to bituminous coal, it contains about 4.5 to 6% of hydrogen. 4.5 to 6% hydrogen is present from peat to bituminous. What happens after that? There will be very less contents in the anthracite. So that is why anthracite is the highest pure coal. So that is less than 1 to 2%. It contains after all 1 to 2% of hydrogen. Then nitrogen. It is present about 1 to 3% in all the types of coals and comes from, where does it come from? Proteinaceous matter. Proteinaceous matter in vegetable matter. So we have studied that peat formation happened from vegetable or vegetation, decomposition or degradation happens. Degradation. From this degradation, the peat formation takes place. So all the proteinaceous matter get converted into nitrogen. What is the proteinaceous matter? Is nothing but amino acids that contains nitrogen, obviously. So inert nitrogen decreases calorific value. So any proteinaceous matter with inert like peat or subbituminous or bituminous, any type of coal having nitrogen in the inert form decreases the calorific value. It decreases calorific value of particular coal. So as coal matures, extractable nitrogen decreases. What does it mean? It means like the extraction of that nitrogen will go down. Like we will not be able to extract that nitrogen from that particular coal as the coal is maturing from peat to anthracite. Peat to anthracite type of coal. Then its portion does not depend on rank. So there is no dependence on the rank. Even if it is peat or anthracite, it is all like 1 to 2% is present. Definitely in 1 to 2% is present nitrogen in all the types of coals. Next is the sulfur. So sulfur generally it increases the calorific value but is undesirable. Why is it undesirable? Because presence of sulfur, what happens on oxidation during combustion? It will form sulfur dioxide and sulfur trioxide. These are harmful. These are harmful. So we really doesn't require these harmful gases to evolve during our practical applications. So its oxidation products in the presence of moisture cause corrosion of equipment and pollution. This is just like because of these gases, there will be corrosion for the equipment and also polluting the atmosphere. So when used in steel making, it badly affects properties of iron and ultimately steel. Steel is nothing but alloy of iron. So whenever we are using for steel making, it affects the properties of iron and thereby the property or the quality of the steel also goes down. So sulfur generally exists in three forms: pyritic, organic and sulfate form. Sulfate is nothing but inorganic forms. So in these three forms, sulfur is present in all types of coals. So worldwide coal reserves contain 1 to 3% of sulfur. So only 1 to 3% of sulfur is present in all the types of coals. So next is the oxygen. So less the oxygen, better is the coal. Why? Because if there is any chance of oxygen presence, what will happen? It forms moisture. So if it is moisture, the consumption will combustion will go down. So that is how the oxygen content should be very, very less. Decreases from lignite to anthracite. So from formation from the lignite to anthracite, the oxygen content decreases. Oxygen content decreases. Oxygen content decreases. That is why anthracite is the highest ranked coal in the world reserves. As oxygen content increases, for example, if there is any increase in the oxygen content, moisture holding capacity increases. So it will hold the moisture and the caking power, forming masses, the power of forming masses will decrease. So the combustion also goes down. So these are the various effects that will cause because of presence of these elements in some quantities. So this ultimate analysis, if we have to perform for the carbon and hydrogen, so we have to take 1 to 2 grams of accurately weighed coal sample in which is burned in a current of oxygen. Current doesn't mean current, it is like flow of oxygen. That is like we are sending pure oxygen from this end and we are taking 1 to 2 grams of sample in a crucible and is kept in the combustion apparatus. So the carbon and hydrogen of the coal are converted to carbon dioxide and water respectively. So carbon will be converting to carbon dioxide and hydrogen to H2O molecules. So the gaseous products of combustion are absorbed respectively in KOH and calcium chloride tubes of known weights. So for example, we are taking calcium chloride here. So here we are taking anhydrous calcium chloride. So be careful that the calcium chloride should be anhydrous. It means no water. No water. Anhydrous means no water. So we have to wait before we take it into the tube and also KOH solution in another tube. So then what happens? The carbon dioxide and hydrogen produced passed through the tubes of anhydrous calcium chloride and KOH solution. So when it is passing through these tubes, there will be increase in the weight of these calcium chloride and KOH weight due to absorption of water and carbon dioxide. Here water will be absorbed, here carbon dioxide will be absorbed. Here we are taking anhydrous, so water will be absorbed, and in KOH carbon dioxide will be absorbed. So we will see in detail how the reactions will go on. So this carbon, when it is reacting with pure air, it will form oxygen, it will form carbon dioxide. So this unabsorption in KOH, what does it form? Potassium carbonate and a water molecule. So again, in the same similar way, the hydrogen content, whatever is present in the coal, is reacting with oxygen and forming water molecule and is absorbed on calcium chloride tube. So this is tube 1, this is tube 2. So calcium chloride tube, this moisture will be absorbed. So this water forming will be absorbed into calcium chloride and forms hydrated calcium chloride. Hydrated calcium chloride. What does it do? It will obviously increase weight. So this will increase weight, right? Because there is addition of water molecule here. So if you want to calculate from this, like percentage of carbon, increase in weight of KOH tube. So we are taking the weight already before we are passing the air and the carbon reacting with it. So before that also and after that also, so that we get the difference. So increase in weight of KOH tube into 12. Where is the 12 coming from? From carbon atomic mass. Carbon atomic mass. And weight of the coal taken. Weight of the coal, like 1 to 2 grams we are taking into 44. What is this 44? Carbon dioxide molecular weight into 100 will give percentage of carbon. So this is very clear, like whatever there is a weight in increase of KOH tube into atomic mass of carbon to the weight of coal sample into 44 is the molecular mass of carbon dioxide. So this is how we calculate the molecular mass from the formula CO2. So this is a 44 we are applying in the formula. Next, the percentage of hydrogen, increase in weight of calcium chloride tube into 2. 2 is atomic mass of hydrogen, and weight of coal taken into 18. 18 is a molecular weight of water molecule into 100. So this will give the percentage of hydrogen that is present in that particular coal. Next is the nitrogen. So in this nitrogen we use Jeldahl method. So in the most of the cases wherever nitrogen estimation is there, we generally use Jeldahl process. So 1 gram of accurately weighed potted coal is heated in sulfuric acid, concentrated sulfuric acid, along with potassium sulfate as a catalyst in a long-necked flask called Jeldahl flask. It is just nothing but it is not different from any other apparatus. It looks like long tube with a round bottom. So this is nothing but Jeldahl flask. It is just different from the standard flask will have a flat end, but Jeldahl flask will have round edge. So this is the Jeldahl flask we use for the nitrogen estimation. So heating of sample to 360 to 410 degrees centigrade with sulfuric acid, concentrated sulfuric acid decomposes, it is nothing but digests or destructs the organic sample. So any nitrogen in the form of organic matter, we have already discussed, like nitrogen is present due to presence of proteinaceous matter that is degraded into coal. So because of that, only the organic compounds will contain nitrogen. So that will degrade due to sulfuric acid. So by oxidation, it liberates reduced nitrogen as ammonium sulfate. So that will convert into ammonium sulfate. So hot concentrated sulfuric acid oxidizes carbon and sulfur present in coal. So this carbon and also sulfur also gets reacted. So we will see in detail how the reactions will take place. The catalyst that we are using will be like selenium or mercury sulfate or copper sulfate are added, that will increase the digestion of that particular reaction. Where is that reaction going on? That reducing into ammonium sulfate. So when we are adding these salts, one of these salts, it will increase the digestion process. And also the alkalis, for example, like sodium sulfate or potassium sulfate is also added, that increases the boiling point. Why do you have to increase the boiling point? So that it attains, it will be sacrificing, like the sulfuric acid will tend to react more with the reactants rather than boiling. So we have to increase the boiling point of the sulfuric acid by adding sodium sulfate or potassium sulfate. So after this, like the solution will become clear. After it becomes clear, it is treated with excess of KOH or sodium hydroxide, and liberated ammonia is distilled over and absorbed in a known volume of standard acid solution. So this is the nitrogen we have in the coal. So we are treating with sulfuric acid and a catalyst like sodium potassium sulfate under heating conditions like 360 to 410 degrees centigrade. Depending on the weight, we will be varying the temperatures. Then it will be converting to ammonium sulfate, and on alkali and heating, it is forming ammonia. This ammonia is absorbed in acid solution. Absorbed in acid solution. So before we are absorbing, before absorption, we have to weigh acid. We have to titrate this acid solution. Titrate acid solution for blank reading, because after ammonia and before ammonia absorption there should be a difference. So that is why we need to estimate the blank reading also. So this, after this is a Jeldal flask that we are reacting, and after that this is the schematic that is showing the formation or the absorption of ammonia into the acid solution. So these ammonium ion concentration in the acid solution, and thus the amount of nitrogen in the sample is measured by titration. So how we are going to ultimately estimate? It is just by titration method, simple titration method we are using. Unused acid is then determined by back titration with standard NaOH. Like we are using acid for absorption. So we have to definitely titrate with a base. So we have to titrate with a base. So what is happening here? The ammonia that is reacting with acid, ammonia on reacting with the acid, that is H plus ions, will form NH4. So this is ammonium ion. Ammonium forming. So there will be remaining acid molecules or the acid contents which is not reacting with the ammonia. That means sufficient ammonia is already reacted, so there is leftover acid molecules that are present, which has to be titrated against a base to obtain the how much ammonia is present in that particular coal. So from the volume of acid used by ammonia liberated, the percentage of coal is calculated. So the volume of acid used by ammonia. So this ammonia, wherever which is absorbing into the standard acid, will use some acid molecules. So that will give the percentage of nitrogen present in the coal. So whenever we are doing acid-base titration, we have to use indicators for the endpoint. So what are the indicators we are using here? Tachiro's indicator, which is nothing but mixed methylene blue and methylene red. This is the pH indicator. Why we are using pH indicator? Because initially it is base, ammonium ion is a base. So this is pH indicator. Acid is titrated with a base like sodium hydroxide. So it will be like giving an exact endpoint to obtain the amount of nitrogen present. So this is the percentage that we'll be calculating using this formula. Volume of acid used into normality into 1.4 by weight of coal that is taken. So how is the formula formulated? It is like volume of acid consumed into normality into 14 is nothing but atomic mass of nitrogen into 100 is for percentage divided by weight of the coal into 1000. For liter we are making it 1000. So when we multiply with 100 and divided by 1000, it becomes 1.4. That is how there is a change in the derivation in the formula. So this volume of acid consumed is nothing but blank titration reading minus back titration reading. So with this difference only gives the volume of acid that is consumed for the nitrogen. Next is the sulfur. So sulfur is determined from the washings obtained from the known mass of coal used in a bomb calorimeter for determination of calorific value. So in the previous session we have seen that bomb calorimeter is used for calorific value estimation. So where we get washings, so that water will be used in sulfur estimation. So during this determination, sulfur is converted into sulfates. So sulfur is converted into sulfates. The washings are treated with barium chloride solution. When barium sulfate is precipitated, it is filtered, washed, heated to constant weight. If at all sulfur is present, when it is treated with barium chloride, it forms barium sulfate. Barium sulfate precipitate. The down arrow indicates precipitation. So if at all sulfur is performed, we get this white precipitate. Otherwise, no precipitation. So that is how we use this precipitate in percentage calculation of sulfur. So this percentage is given by weight of barium sulfate obtained into 32 by weight of coal sample in the bomb. Weight we have taken in the bomb into 233 is the molecular weight of barium sulfate into 100. So this is how we use the calculation for estimation the percentage of sulfur. So the sulfur that are present, if ever present in coal, on oxidation will give sulfur dioxide, and upon again oxidation, keeping on oxidation, it forms sulfur trioxide. So when it is dissolved in water, in the bomb calorimeter, if you remember, there is coal sample that is liberating gases. So this will be dissolved in water. This is whole apparatus is connected to whole apparatus is dipped in water. So this water will contain this water, whenever sulfur is dissolved in sulfur trioxide, dioxides dissolve in water, forms sulfuric acid. So this sulfuric acid on reaction with barium sulfate forms barium chloride forms barium sulfate. So this percentage calculations are done. So the barium from this barium sulfate molecular weight is calculated from barium, sulfur and oxygen atomic masses, which is 233 gram per mole, and 32 is the atomic mass of sulfur. Atomic mass of sulfur. So that is giving us the percentage of sulfur that is present in the coal sample. Next is the ash content that we have already seen in the proximate analysis, which is used. So this ash content from the proximate analysis will be used in the calculation. So we will have a glance like percentage of ash is obtained from whenever it is heated at 750 degrees centigrade in a muffle furnace. Why we are using muffle furnace? Because we require high temperatures like 750 degrees centigrade. For half an hour will burn the coal completely. That will form ash residue. So the ash, whatever is formed, taken to weight of the coal into 100 will give the percentage of ash. So where we are using this ash percentage in the calculations? In oxygen percent. Why we have to do only theoretical percent? theoretically, because during all this process there is an escape of oxygen, so it is very difficult for the oxygen to calculate. So 100 minus percentage of carbon, percentage of hydrogen, percentage of sulfur, percentage of nitrogen, and percentage of ash, the sum of all these to be subtracted from 100 to obtain percentage of oxygen. So this will give a percentage of oxygen for present in that particular coal sample. So what is the significance of this ultimate analysis? Why do we really have to carry out ultimate analysis? So this is a convenient method for reporting major organic elemental composition of coal. So organic elemental composition, which is nothing but HNSO, hydrogen, nitrogen, sulfur, oxygen content, and carbon content in coal. So whatever is the coal, we have to estimate the organic elemental composition. So for that, this is a very convenient method which is used since long ago. So carbon, hydrogen, why we have to do? The greater the carbon content, so the percentage of carbon, if it is in higher percentages, the better will be the coal, its properties having good calorific value. So however, hydrogen is mostly associated with volatile matter. It is present in the form of volatile matter, and hence it affects the use of other coal which is put. It means, like for example, if we are not removing the volatile matter before its application to any industry, the volatile matter will escape during its application. So there will be change in the energy that we obtain during the applications. Also, higher percentage of carbon in coal reduces the size of combustion chamber required. So it is good, like combustion rate or the combustion chamber should be reduced. So high percentage of carbon is good to have. Amount of carbon, major combustible constituent of coal, depends on type of coal. So this is nothing but ranking. We have seen the ranking, like depending on the ranking, there will be percentage of coal that is present. So this is a major part that we have to consider for any calorific value, and finally the application part. And its percentage increases with rank from lignite to anthracite. So carbon percentage increases. Carbon percentage increases from lignite to anthracite. So obviously, because there is mature or the coal will mature from lignite to anthracite, therefore the carbon percentage is increasing. Thus, carbon percentage forms the basis of the classification of coal. So when this percentage of carbon estimation is important for classifying that coal into different types. Then nitrogen has no calorific value, and hence its presence in coal is undesirable. So the percentage of nitrogen is not required and desirable. So whatever percent we get has to be removed. If at all not removed from the coal, what happens? In volatile form, it is like ammonia, cyanide and tar nitrogen, which is hazardous to the environment and also to the human's health. So that is why it has to be removed. Otherwise, it will be chairing the process where we are applying for. So this volatile nitrogen has to be removed in any ways, like the percentage of nitrogen that ever is present will be removed during its processing. So in gaseous form, it is present in the form of ammonia or cyanide. So these are also isocyanates or cyanates. These are also harmful, shows harmful effects. So therefore, to be removed prior to its applications, in industries, so that the labor working will not have any harmful effects. Then sulfur, it attributes to heating of coal. Although it will increase the calorific value, the presence of sulfur will produce acids like carbon dioxide and carbon trioxide. So these will have harmful effects, corroding the equipment and also atmospheric pollution. So this will cause corrosion of equipment that we are using, and also pollution to environment. So therefore, we don't need sulfur in the coal. Sulfur is usually present in 0.5 to 3% and derived from ores like iron pyrites, gypsum, mines along with the coal. So during mining, coal mining, there will be metal ores also present in the earths. So during mining, what happens? All these will be extracted. Along with the coal, we get the sulfur in that form. So this extraction happens. So presence of sulfur is highly undesirable to coal used for making coke for iron industry, since it is transferred to the iron metal and badly affects the quality and properties of steel. Steel is a major product we use in our daily life and also for the construction purpose. So this presence of sulfur will affect the iron material and also ultimately properties of steel. Moreover, oxides of sulfur pollute the atmosphere and leads to corrosion. So that is why we really doesn't require the sulfur to be present, therefore to be removed from the coal before its application to any industries. Oxygen decreases the calorific value, therefore ultimate analysis gives a good idea of how much oxygen is present in particular coal. So high oxygen content coals are characterized by high inherent moisture. What is inherent moisture? Presence of oxygen in coal in coal molecules. Like for example, within the network of that coal, what is adsorbed? If it is adsorbed, it is like top layer, only the top layer of the coal will be having, but inherent moisture is inside within the molecules of that coal, so it will cause a low calorific value and low coking power. So moreover, oxygen is in combined form with hydrogen in coal, thus hydrogen available for combustion is lesser than actual one. So oxygen, when it is in the combined form with hydrogen, what does it form? Like moisture. So our estimation of hydrogen is different and the presence of hydrogen in that particular coal is different, because hydrogen is present along with the coal in the form of moisture that will restrict the combustion. An increase in 1% of oxygen decreases the calorific value by 1.7, which is by rounding off, like it is double the amount. Like 1% of oxygen, if it is present, 2% of calorific value will be reduced. So hence oxygen is undesirable. Thus a coal, good quality coal should have low percentage of oxygens. So low percentages of oxygen should be present in coal for better application. So in the summary, we see that percentage of carbon, CHNSO. This is the ultimate analysis. So increase in weight of KOH tube into 12 by weight of the coal sample taken into 44 is for carbon dioxide. This is carbon into 100. So this is atomic mass and molecular mass of carbon dioxide. Percentage of hydrogen, weight, increase in weight of calcium chloride tube into 2, that is hydrogen atomic weight, and weight taken to weight of coal sample taken into 18 water, that is forming into 100. That will give percentage of hydrogen. So next, percentage of nitrogen. In this, volume of acid used in the Jaldal procedure into normality of that acid into 1.4 by weight of the coal taken. Here we are not taking 100 because it is already given in the calculations. Then percentage of sulfur, weight of rearranged equation. Weight of barium sulfate obtained and atomic mass of sulfur by weight of coal sample taken in the bomb into 233 is the barium sulfate molecular weight into 100 will give the percentage of sulfur. Then at last, the percentage of oxygen is subtracted the sum of percentages of carbon, hydrogen, sulfur, nitrogen, ash from 100 will give the percentage of oxygen. So these will give a better idea of what type of coal is being mined, so that immediately after proximate analysis, we do ultimate analysis for this elemental purpose. So in this session, we have learned all the analysis of elements that are being analyzed. So in the next session, we will see liquid fuels. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.